Welcome back, guys. So today we are going to solve part B of our question 2.1, and here t of x of n is equal to summation from k is equal to n not up to n x of k, where n is not equal to 0. So let me write it here. T of x of n, that is equal to the summation from k equal to n not up to n, and here x is k, where n is not equal to 0. Okay, so again, let us first find whether this is stable or not. So in order to find the stability of it, we don't know that what is the value of n naught and what is the value of n and where it moves. Okay, so therefore when the x of k number of items will be added, so let us suppose that from n naught up to n we have the m number of items. Okay, so here it would be m of x of n. Okay, so we don't know that whether this value is higher or lower or whatsoever, so therefore this system will be unstable. Okay, because this value, if is higher, it will make this system unstable, so therefore the system is unstable. Okay, this is not stable. So now let us remove it. Now in part B, we have to see that whether this is causal or not. Okay, again, as we don't know about whether this n naught is before the present value or after the present value. Okay, and similarly we don't know about this, and therefore this x of n naught will start from here and it will be added up to x of n. Okay, we don't know whether this is negative, these are negatives, these are positives or whatsoever. Okay, so we cannot say anything about its causality, so therefore the system here we have is non-causal system. Okay, again, the third one here is to see the linearity of a system. Okay, so to see the linearity of a system, again the formula we have here is t of x 1 of n multiplied by a plus t of b multiplied by x2 of n. Okay, so when these will be added, we will have here a t of x1 of n plus b, the multiplicative factor t x 2 of n. Okay, what it will do, let me move down somehow. What it will do here is that this is a, and here it will do with it that it is k is equal to from n naught up to n, and it will become x1 of k plus it will become k equal to n naught up to n x2 of k. Okay, so this is the first one. Similarly, in order to see the other part of it, we have here a of x1 of n plus b of x2 of n. Okay, so ultimately, as this is the addition, so therefore it will be what? It will be as it is, so it will be t of x1 of n plus t of b x2 of n. Okay, so it is the similar one as that is here, and ultimately it will give us the similar answer as we have here. So therefore this is equivalent to this one, these two are also equivalent, so therefore the system here we have is the linear system. Okay, so the system here is a linear system. Now the fourth one is the time invariance. So let me check it out. To check the time invariance of a system, again we have a system here. Okay, let me delay the x of n, and then we have to provide this delayed signal to our system, and here we will get some value that is x, and again when the same input is applied to the similar system, and after it is applied to the delayed one, this is what we get y. If x is equal to y, we will have the time invariant system. So let's see what happens here. If this is here, so it will become x minus x and minus n naught. So when it will pass through this system, what it will do, the processing it does is over this n. So therefore at this one, x will become what? X is, this will become x equal to n naught up to n. Okay, and it will do what? This is if k, so this will become x of k minus n naught. Okay, so it will be the value of x, which is here. Okay, so now this is for the value of x. Now to find out the value of y, this x of n will be applied to this t, and at the output of it, this is the processing which is does over this x of n. So here we will get k equal to n naught up to n, and here x of k. Okay, and when it will be passed through this n naught, what it will do is that it will only delay this n terms wherever these, and it will delay it. So therefore here the output y will become what? The output y will become from n naught to n minus n naught, because here this n and it will be delayed by n naught, while this x of k will remain the same. So therefore this is y. Okay, so we can see that here x is not equal to y. So therefore this system is not time invariant, but the system is time variant. Okay, so we can write here as well. Okay, so that is for the fourth one. Now to see the memorylessness of a system, whether the system is memoryless or not. So we don't know whether this n and n naught are from the previous one or the past one, and similarly it is adding all these things. Okay, so therefore it must have the memory to store the previous samples so that it can add them together. So therefore the system is not memoryless, but a system has a memory, so therefore it is also not applicable here. Okay, so that is for the part B of our question. In our upcoming videos we will try to solve the other parts. I have solved all these parts separately to establish a firm concept in your mind so that you will be able to solve other parts very easily. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon.